Okay, good morning, everybody. All right, so we were talking about this period class at the end of the last lecture. So remember, the topic that we're currently in is aggregation and composition, and we're discussing composition right now. So we wanted to make this period class where a period represents a period in time. So it has a start time and an end time, where the start time is always before the end time. And so far we've gotten to the point where we've got our period object is a composition, right? So remember, solid diamond represents a composition of two date objects. Of two date objects. Right? Now remember, in a composition, anytime you're doing something with a field that belongs to the period object, where you might either be changing the date, so you might be changing the start time or the end time, or you might be returning the start time or end time. You have to remember that you have to return a copy of the date object. If you return a reference to one of the internal date objects, or if you end up sharing a reference to one of the internal date objects, then you have a broken composition, right? You don't actually have a true composition. So let's just quickly scroll through. We've actually looked at this, looked at most of the implementation already. So there's our period class, right? It has a start time and an end time, represented using two date objects. So in the constructor, this is the side we were at last class. So this is the correct way to implement the constructor for the period class. So remember that the period class has this invariant where the start time has to be before the end time. So before you set this start or this end, you make a copy of the incoming start time and end time, right? So you make a copy. We do that using one of the date constructors, and then you validate the copy, right? So check if the start time is greater than the end time, right? So if the start time is greater than the end time, that means that the start time comes after the end time, which is not allowed, right? Because start time always has to come before the end time. So we throw an exception. Right? Only after you validated the copy can you go ahead and set the start and end times. Here's the copy constructor for the period class. Well, this is an incorrect copy constructor. Right? So if you're implementing an aggregation, this is fine. Right? You just set this start equal to the other period's start time. Right? You can set this end time to the other period's end time, right? Which is fine in an aggregation, but it's not good in a composition. Right? Because in a composition, if you write this, right, then what you're saying is that the start time for this object is the same object as the start time for the other object. Right? And you're saying the start time for the end object is the same object as the end time for the other object. Right? And what does that mean is whenever you use the copy constructor, you end up with two period objects that share the same start and end object. Right? If one object changes the start time or end time, the other object also sees the change start time or end time. Right? Which is not good in a composition. Right? So what do you do to fix the problem? You make a copy of the other period's start time and end time. Right? How do you make a copy of a date? Well, you write new date. Right? And then something to get the other date's time. Right? How do you make a copy of the end time? Well, you write new date. Right? So in a composition, you're always making, not always, you have to pay attention to when you need to make new objects. Right? Again, if you're if you want to implement period as a composition, right, you have a method that returns the starting time of the period. Right? If you return this dot start, you have a privacy leak. Right? You've given somebody a reference to that date object. Whoever gets that reference can change the date object, can mutate the date object, and then the period start time now changes. Right? Which is weird because the method's called getStart, right? But you can use the object that's returned to change the start time. Right? So in other words, you can use the object that's returned to set the start time, which is unusual. At least when you're implementing a composition. Right? Similarly for getEnd, don't return this dot end, right? Instead, make sure you return copies of the two objects. And then finally, let's an example of one of the mutator methods. So if this is an incorrect implementation. If you have a method that lets the user change the start time by passing in a new date object, right? Whatever you do, do not write right? This start equals new start, right? Because if you write that, you're basically saying I'm willing to share ownership of this start time object, right? Instead, right, make the copy, right? Validate the copy, and then only after the copy is validated can you set the start time. Right? Okay, so that's enough composition for now. So a privacy leak occurs when a class exposes a reference to a non-public field that's not primitive and mutable. Right, so if you have primitive fields, none of this matters, right? Because Java uses, there's no way to return a reference to a primitive field, right? You can return the value of a primitive field, but you can't actually return the field itself, right? If you have an immutable object, again, none of this matters, right? So if your fields are strings, for example, it doesn't matter because you can hand out a reference to an internal field and no one can change it, right? Because the object that you're handing a reference to is immutable, right? So again, none of this matters. When you have a mutable object, that's when this matters, right? If you have a mutable object, you've got some invariant on that object, right? Then whatever you do, you cannot hand out a reference to that object, right? Because then someone who gets the object can just change it, can just call a mutator method on it, right? So all of these examples, these are all privacy leaks, right? So privacy leak occurs when you're implementing a composition and you hand out a reference to one of your fields that's one of the part objects, right? This y equals y means that you're willing to share the incoming y object, right? Get y, if you return this y, that means you're willing to share your internal object, right? In the copy constructor, if you write this y equals other y, it means you're sharing the internal y object with another x object, right? And in set y, this y equals y, again, it means you're willing to share your internal y object with somebody else, right? Whoever called the method. So why can you not do this, right? Or why should you not do this? So if you're implementing a composition, right, a privacy leak allows some other object to control the state of the object that leaked the field, right? So what does that mean? The object state can become inconsistent, right? So for example, if a credit card exposes a reference to its expiry date, right, then whoever gets that date can change the date and do something like make the card expire before it was issued. Right? In the example that we're just talking about, right, if the period class exposes a reference to one of its internal date objects, right, then it's trivial to change that date object so that the period class can no longer guarantee its invariant. Right? So in other words, it's possible to change a period object so that its start time comes after the end time. You now have if this happens, you have a broken composition. Right? Because the object no longer owns or has exclusive ownership over its own field. Right? So in other words, when an object dies, its parts no longer die with it. Right? So remember, composition implies exclusive ownership. Right? So if a period object owns its two date objects, then when the period object is no longer needed, right, it can be garbage collected, but that also implies that its internal objects can also be garbage collected. Right? So in other words, the two date objects can go away as well. If you hand out a reference to one of those date objects, then the garbage collector will not remove that date object from memory, right, until the other reference goes away. And so now when your object dies, the parts don't die with it. Okay, now a few weeks ago, I think, we talked about how to make an immutable class, right? And there were 5 rules for making an immutable class, right? Anything in black, we know why you need these rules. Right, so one's obvious. If you want an immutable object, don't provide a method that can mutate the object. Right? You should make your fields final. Right? Remember what a final field does? A final field, you can only set it once. Right? So if you set the field once, no one else can change it, including yourself. So that's also that's also useful for implementing immutability. You should make all your fields private. So that's to make sure that no one outside the class can access the field directly. Right? And then we have these 2 in red and blue. So the red one we still don't know about yet, but the blue one we now know. We now understand the reason, or you should now understand the reason why you need that rule. Right? Prevent clients from obtaining a reference to any mutable fields, right? Because if you give them a reference to a mutable field, they can mutate the field, right? And now your object state changes. So in other words, when you're implementing an immutable object and you have inside of it an object that's mutable. So for example, a list or an array, right, or a date, right? You have to make sure, you have to basically use composition, right? Don't hand out a reference to that internal field. Immutability is another example of a class invariant, right? If a class says that it's immutable, then it promises that its state never changes, which is assignment 4, right? In assignment 4, you're implementing an immutable binary number. And finally, rule 2, we'll talk about, I think, in a week or so. Okay, composition with an array. Now, so what happened? So this was what we just talked about. You have a composition. We had a period object. It's composition of 2 date objects. Right? As soon as you have a collection of objects inside of another object, this now introduces a second problem. Right? So your second problem is, right? Should the object own its internal collection? Right? So do you own the array or do you own its internal list? Right? Problem number 2 is, do you own the elements in that array or list? Right? I guess problem number 3 is does the array or list own its elements? Right? And we don't actually know the answer to that yet. Right? Okay, so if a class has a field that's an array is mutable, right? I can change the elements in the array. So now I have to consider, am I using aggregation or composition? If you have an array of primitive type, right? So you have an array of int or array of char, then problem number 2 goes away, right? You only care about, do you own the internal array or not, right? So if your fields, if your array or list, so if you have an array that has reference types in it, that's when problem number 2 occurs. We'll talk about that in about 20 minutes. Okay, I want to implement a simple class to represent a combination lock. Right, so this is like one of those cheap bicycle locks that's got those little dials on it. Each dial has a number between 0 and 9. Normally there's 3 or 4 dials, and you just change the dials to match the combination, and that unlocks the lock. Right, so that's what we want to implement right now. We're going to make it a little fancier. So we're going to have a combination lock where there are at least 3 digits, but there can be more. Right? And the maximum number of digits is unspecified. Right? So you need now you need some collection to hold the numbers of the combination. Right? Because the maximum number is unspecified. Right? If you said there was only 3 numbers in the combination, then you could just use 3 fields. Right? But because we don't know the actual number, you have to use a collection of some kind. And furthermore, the other thing about the lock is that it's always locked or unlocked. And that's it. So it's pretty simple to implement this class. You need some sort of collection to store the combination. And you need some variable to indicate whether or not the lock is locked. Right? So because the lock is only in 2 states, you can use a Boolean to represent the state of lock. Right? True for locked, false for unlocked. You could also use an enumeration here if you wanted to. But in this case, it's probably fine to use a Boolean. I don't know why this lock is implementing comparable. We're not actually going to do that in this lecture. It's a bit strange to implement a lock that implements comparable. But anyway, the combination of the lock, I'm just going to use an array of int. Right? The state of the lock, I'm just going to use a Boolean. Okay, now, remember when you write something like this, right? When you make a field that's an array or a list or any other object, right? There's no object yet that's made here, right? So in other words, combination, you declared it to be an array of int, but there's no actual array yet. Right? That's not the way Java works. Java does not make an array for you automatically, right? So in your constructor, you're going to have to make an array and store it in combination. Right? So all of your constructors are always going to be making new arrays as follows. Right? So here's the no argument constructor that initializes the lock so that it's locked and it has the combination 999. Right? So this might be when you get the lock brand new from the store. Right? So you're going to make you'll make the array. Right? It's got 3 digits in the combination, so you make an array of size 3. Right? You just set each digit to 9, and then you set the lock. You set is locked to true. Right? So that's easy. You'd have to do this whether you're using aggregation or composition. Okay. Now, if you take the combination from the caller, right, as an array, right, now this is when you're worried about composition, right? So if you're receiving the combination from the user, now you have to copy the user's array to make sure, because you don't want to share the same array with the user, right? You then have to validate the copy. Oops, sorry. Right, so this one's the copy, sorry, not the copy constructor. The constructor that takes in an array of int that represents the combination should copy that array, then validate the elements in that array. Right, now, this is actually an incomplete validation here. So to do the copy, you could make the array and then write a loop to copy in the elements yourself. Right, but if you ever have to copy an array, then the easiest way to do it is probably to use arrays.copyOf. So arrays is the utility class that's part of the standard library that has methods supporting arrays. Copy of will copy that array. Right? Now remember, that array is that array right there. Right? And you can ask for how many elements to copy out of that array. Right? So if you want to copy the whole array, it's just combination, comma, combination.length. Right? If you wanted to copy in only part of the array, you would change that second number. Right? If you make that second number bigger than the length of the input array, and then it makes a new array where all of the remaining elements are initialized according to whatever rules apply to the type of the array. Right? So if this was an array of int, then it fills it all with zeros if that number is bigger than the length of the combination. Okay, so we copied the array. I now have to validate the array, right? So remember, our combination lock says that there's always at least 3 numbers in the combination. So I check, right? Is the length of the combination at least 3? What's not checked for here is that the numbers are supposed to be between 0 and 9. So I don't actually check for that, but you would write a loop in here as well. You'd write a loop after, right? And check to make sure each number is between 0 and 9. Only after you've copied and validated the array can you set this combination to equal the copy and then set the state of the lock to be true. Right, so again, it's just straightforward composition here. Copy constructor has to do something similar. Right? So the copy constructor, right, that's the constructor that takes in another combination lock. Right? So here you could repeat yourself all over again. Right? So I could do I can do most of this again. But in this case, it's easier now just to chain to that constructor I just wrote. Right? So remember how constructor chaining works? On the first line of a constructor, you're allowed to call another constructor. Right? I would like to call the constructor I just wrote, passing in the combination of the other lock. Right? So that will call the second constructor. The second constructor will do all of the work it needs to. Right? And then, when it's done, we can set the state of the lock to the state of the copied lock. Right? So this locked equals other is locked. Now, there is a price here that you pay for the constructor chain. Right? So if someone's going to call this constructor, they need a combination lock to call that constructor. Right? So someone needs an existing combination lock. The only way you can have an existing combination lock is if that lock was constructed already, and the state of that lock is valid, right? Assuming the rest of your class is implemented correctly. Right? So in other words, that other combination that comes in, you know its combination has at least length 3, and you know that, well, hopefully you know that the digits are between 0 and 9. Right? In other words, the other lock is a valid lock. So when you chain, you end up validating the lock that you know is already valid. Right? So there is a price here that you pay for using constructor chaining. The price that you pay is the unnecessary validation. Right? Now, in this case, it doesn't matter, because even if the combination was huge, the validation is not going to take very long to do. But in cases where it's very expensive to do the validation, you might want to consider not chaining, or chaining to a private constructor that doesn't do any validation. Right? But that's a little bit beyond the scope of what we're talking about right now. Okay, now, one of the problems when you talk about aggregation and composition is that a lot of students automatically default to composition So they don't even consider aggregation, right? They just say, well, I'm just going to use composition to be safe. And then they copy objects all over the place. So every time they need an object for some reason, there's a copy made, right? And again, I guess it's this paranoia that you have to copy objects, right? That's not true, right? So number one, you don't want to copy objects unnecessarily in any language because the copy takes up memory and it takes up time to make the copy, right? And then it takes up time to get rid of the copy later on. So you want to avoid making unnecessary copies of objects. Oh, actually, that was one of the reasons why in the early days, Java was considered to be a very slow language because people were making objects unnecessarily. And that's true in most object-oriented programming languages, right? You want to avoid making objects if you can. Right, so not every method requires a defensive copy. So for example, if you want to unlock the lock, right, someone's going to pass in an array of, someone's going to pass in a combination to compare against your combination, right? If the combinations match, you unlock the lock, right? There's no reason to copy that incoming array, right? Just use the array and check if it's equal to your array, and away you go, right? Right, so for example, if you're going to unlock the lock, right, where you take in an array containing the combination, right? The lock is unlocked if that combination is equal to the lock's combination, right? So how do you check if two arrays are equal? You use arrays.equals, right? Compare your combination or the combination of this lock to the incoming array. If they're equal, so equals for arrays means they have the same length, and every corresponding element in the two arrays are also equal. Right? So if the arrays are equal, you know the combinations match, and you just unlock the lock. Right? If the arrays aren't equal, nothing happens, right? Which is exactly what you want to happen, and that's it. Right? So when you have an array when you have an array of primitive type, then composition behaves more or less the same way as composition for the period class. All right. Any questions about composition so far? Okay. But as I mentioned, things do get a little bit more complicated when you have a list or something else. Okay, so what happens when you have a collection as a field, right? So now I have a list or an array or a set or a map, right? Or some other collection, right? Inside that collection, there are reference types. Right. Now you have to decide whether or not, when you implement a composition, do you own the things that are inside the list, inside the other collection? Right. So this happens a lot. Right. So often you want to implement a class that has a collection as a field. Right. Now has a, right, that immediately implies association. Right. So now you're going to decide between aggregation or composition probably. Right. So for example, a university has a collection of faculties. Right? Each faculty has a collection of schools and departments. Right? So if you're going to implement a university class, you're probably going to have some sort of collection for the faculties, probably going to have some sort of collection for the schools and departments. Right? You might have a receipt, right, for some sort of billing system. Right? What does a receipt have? Well, it's got a collection of billable items. A contact list for your phone has a list or a collection of contacts. That's not true, not from the notes. A student, if you're implementing a student class, might have a collection of GPAs and a collection of courses. Right? And furthermore, so if you're implementing a class that represents a three-dimensional object of some kind, right, then it's very common in computer graphics that you implement the object as a collection of triangles. Right? In general, they can be polygons, but in practice, it's almost universally triangles. Right? Okay, now, you've got a list or a set or a map. What exactly does that thing hold? Right? Does the collection hold the objects themselves, or does it hold references to the objects? It turns out it holds references to the objects. So if I make an array of dates, a list of dates. If I make a list of dates, I make 3 dates, and then I add them to the list. Right? Now the question is what happens to that array list object? Right? So this is what happens. So here's my program running, right? Dates, that's my list, which is here, right, at address 200. Right? I've got my 3 date objects, D1, D2, D3. Right? They're not shown on the slide, but they're somewhere in memory, right, at address 500, 600, and 700. Right? When I add D1, D2, and D3 to the list, what goes into the list? Right? So it turns out it's just it's a reference to the object D1. Right? It's a reference to the object D2, and it's a reference to the object D3. Right? So in other words, it's the references that go into the list. Right? So your list is an aggregation of elements. Right? It does not make a copy of D1. Does not make a copy of that date and put a reference into the list. Right? It doesn't make a copy of that, and it doesn't make a copy of that. Right? It actually puts in. It's actually aggregation. Right? Okay. So what does that mean? Right? What happens if I make a list of points? Right? I make a new point P. I add P to the list. Right? And now using P, right, I change the x coordinate of P to 10. Right? So it was 0, 0. I change it to 10, 0. Right? What happens when I print out P? And then I ask the list for its first point and print out that point. Right? So make P, it's 0, 0. Add P to the list. Change the x coordinate of P to 10. Print P. Right? So the x coordinate of P is going to be 10. Right? So it's either C or D. Right? The only question is what happens when I ask the list for element 0? Right? Which point do I get back? Right? Well, I just go back and look at this picture here. Right? So if I put D1 into the list, right? I ask for D1. I ask for the first element of the list. Well, it's also D1. Right? So when I put P into the list and ask for the first element of the list, I get back P. Right? Or I get back the same object that P refers to. So if P is 10, 0, then the object I get back also is 10, 0. Right? It's the same object. So the answer here is D. Any questions about that? Right? So the list is just holding references to existing objects, right? And a list is just an aggregation of elements. Right? The other way to talk, you'd also say that a list is just contains aliases to existing elements. Right? It doesn't make any new objects. Here's an example of a class you might implement. Right? We're never actually going to do this sort of thing, but you might. This is another example. Right? So if you had a student class, right, you got these open diamonds on the student object, so or the class, I guess. So you know this is aggregation. Right? A student has an ID, so there's your one object that represents the ID. Apparently, we're going to use a string. Right? Now, if you have a collection, right, so a list, for example, of GPAs, right, then the way you draw the UML diagram is that you do not draw the list. Right? So you might think that, oh, I should put a list in here, right? But that's not the way that most people will draw their UML diagram. Right? Instead, what they'll draw is that they'll draw the element type instead. Right? So a student is an aggregation of 0 or more GPAs. Right? In other words, it's not a student is an aggregation of a list of GPAs. Right? It's a student is an aggregation of 0 or more GPAs. Right? And that's because you don't necessarily want to lock yourself down to using a list. Right? You might later on decide that I want to use an array or a set or something else. Right? Maybe a map of some kind. Right? And so that way, in this way, you can capture the relationship that a student is just has a bunch of GPAs. Right? Similarly, student has 0 or more courses. Right? Not student is an aggregation of one list that contains courses. Right? So normally the collection is not shown. If you have a good reason to show the collection, though, you can go ahead and do that if you wanted to. Okay, now what about this PolygonalModel class? So I want to sort of, kind of, implement a class that lets you represent a three-dimensional object. Right? So a polygonal model is just an aggregation of 0 or more triangles. Right? Now, what's in a triangle? Well, a triangle is an aggregation of 3 or more points. Right? Okay, so there's an example of a polygonal model. This is a very old slide now. This was generated using, I forget which version of StarCraft. This is an old version of StarCraft that I generated this with. Anyway, in most modern video games, right? Most modern 3D video games, not the 2D ones. The 3D ones, everything's just a bunch of triangles, right? Sometimes the triangles are very big, right? So notice that the ground triangles are very large, right? The ball, it's made of a bunch of triangles, even though it looks round, right? If you ignore the silhouette of the ball and the apple, right? They look like they're round or smoothly shaded objects, right? They don't look like they're discrete triangles. The way this is done, well, the basic way that this was done was I figured out in the 1971, I think. So there's a shading model called Phong shading, which is used to fool you into believing that these surfaces are in fact smooth and continuous rather than being discrete triangles. Right? Pixar's technology works this way. So Pixar's technology takes an object that might be represented as some smooth surface and then just decomposes it into triangles until you get many triangles per pixel. So even in like a many hundreds of millions of dollars movie, it's just triangles, right? Which is kind of surprising. They're triangles because a triangle is guaranteed to be flat, and it's easy to deal with flat objects. Right? Okay, if you take CISC124, the computer graphics course, you'll learn all about this stuff. All right, I want to make a class that represents one of these models, right? So it's just a bunch of triangles, right? That's all. So I'm going to make a list. I have a list of triangles, right? What does your constructor have to do? Well, your constructor does what it always does, right? It initializes the fields of the object, right? That thing try, there's no list yet, right? It can refer to a list, but there's no actual list. So you make the list, right? This one happens to make an empty list. So this is a model that has no triangles in it. I've got a clear method, so that will remove all the triangles from the list, or from the model, I guess. How do you implement it? You just call clear on the list. Right? If I want to know how many triangles are in the model, I just ask the list for how many triangles are in the list. Right? So this is very easy to implement. But you have to decide, right? If I have a polygonal model, right, does it actually own the triangles? Does it own the points that are in the triangles? Right? Or does it just own the list, or does it not even own the list? Right? So there's all sorts of ownership questions here now. So when you're using a collection as a field of a class, you need to decide on ownership issues. Right? Does X own or share its collection? Right? So in other words, are you going to use an aggregation or composition to store the collection? Right? Once you've decided that, you have to decide if X owns the collection, does it actually own the objects that are inside the collection? Okay, so X shares its collection with other X's. Okay, so here we're implementing aggregation, right? So we're going to do all three, right? We're going to do polygonal model does not own its collection, right? If it doesn't own its collection, it doesn't own its triangles, right? Polygonal model owns its collection, doesn't own its triangles. Polygonal model owns its collection and its triangles, right? So part one is aggregation. Right? So if you're implementing an aggregation, and you have a list or a set or a map, right? Then it doesn't matter what you do, right? You don't have to make a new copy of the list or set or map every time. Right? So for example, if I'm going to copy another polygonal model and I'm going to use aggregation, right? You just write this try equals other try, right? So you just get a reference to the other polygonal models list of triangles. And set it to your list of triangles. Right? For get triangles, you just return your reference to your internal list. Right? Okay, so what's the memory diagram look like in this case? I'm going to make a new polygonal model of an existing model P1. Right? So here's P1, right? So P1 is the object at address 200. Right? There's my model object. Right? What's inside of that object? Well, there's a list of triangles. Right? Where does that list live? That's at address 700, so up here. There's my list of triangles. What's inside the list of triangles? Well, there's a triangle object at address 1000, so there it is. There's another one at address 1100, and there it is. Right? What's inside the triangle objects? Well, there's references to 3 points. right? And you can go and you can keep on going, right? So notice that every time you have a reference to something, right? So there's my reference to the model, right? That thing might have a reference in it, right? So there's my reference to the list. That thing might have a reference to it, in it, right? There's my reference to the triangle. What's in here? More references, right? References to 3 points. Okay, so I make a copy using the copy constructor, right? So what happens? So there's a new model, right? New, right? So there's a new polygonal model. So there's a new model at address 500. But what's in that model, right? Well, there's a reference to a list, right? But it's the same list as that, as for that object there, right? So they both point at that list of triangles there. If you modify this list of triangles, right, both objects see the modification. If you modify any triangle inside the list, both objects see the modified triangle. Right? So, for example, right, I make a copy using the copy constructor. I then clear the second model. Right? I think there's supposed to be 100. Right? So there's 100 triangles in P1. Right? I make a copy of P1 and then I clear P2. Right? What's the size of P2? 0. What's the size of P1? Right? Well, it's also 0 in this case. Right? Why is it also 0? Because, right, they both have a reference to the same list. So if you clear this list, the size of that list is 0 and the size of that list is 0. Right? Okay, so that's what happens in aggregation. Right? Again, not a flaw of aggregation, right? So you might think that, oh, hey, this shouldn't work this way, right? But if the documentation for the polygonal model class says everything's an aggregation, right? In other words, it's sharing its list of triangles, right? Then this is exactly the way you expect it to behave, right? You might ask yourself, why is it doing it this way? It's because it doesn't want to make a copy of the list every time, right? In particular, because polygonal models can be very large. So especially in a modern, well, in a movie anyway, even in a modern video game, your models can end up being pretty large, so thousands or tens of thousands of triangles. Some of the stuff I do for computer-aided surgery, it's not unusual to see models where there's hundreds of thousands or millions of triangles. Right? If you don't want to be making copies of those things if you don't have to. Okay, now what happens if X owns its collection? Right? So suppose you don't want this to happen, right? Suppose when you clear the model, right, you don't want all the triangles to disappear in both models, right? You only want it to disappear in B2. Right? So in that case, you might decide that, hey, maybe the object really ought to own its collection. Right? But it doesn't own the stuff inside of the collection. So owns collection, doesn't own the stuff inside the collection. Right? So if that's the case, then we call, you have to make a copy of the collection, right? But you don't copy the stuff inside the collection. So that's what's called a shallow copy. Right? So a shallow copy of a collection means you make a new collection, right? In this case, we're going to make a new list, but it does not make new copies of the elements in the collection. Right? So what does that mean? It means that the stuff inside the collection, those are just aliases for references in some other collection. Right? So in this case, okay. Now this is unusual. The picture here doesn't change. Right? It's still an oh, right. The picture here doesn't change, right? So this is still an aggregation of triangles, right? The list isn't here, right? So the list holding the triangles is not shown in the diagram, right? But we've decided that the model is going to own its list. It's not going to own its triangles, right? So this is still an aggregation of triangles, right? It's just that we want to own the internal list, right? So if I'm going to copy another polygonal model object, I have to make a new list, right? And so there's a hard way to make a new list, right? So that is, there's a hard way to make a copy, a shallow copy of a list, of an existing list, right? So if I want to make a shallow copy of a list of dates, right? Make a new list, right? And then loop over the list and add every element of the copied list into the new list, right? So write a loop to the copy, add every date that's in the original list. Right? Now what does that do? Well, that doesn't make, right, it doesn't make a copy of D every time. Right? So in other words, it's not making new date objects. It just made a new list. Right? Everything you put into the list, it's just a reference to another object somewhere else. Right? So don't write your loop. Don't write the loop yourself. Right? Just call the list copy constructor. Right? Because that's exactly what the list copy constructor does. So if you want to make a shallow copy of a list, right, make your list and just pass in the list that you want to copy. Right? And that gives you a shallow copy of the list. Right? If you change an element in either list, the other list sees the change. Right? So if you change the date in list 1, then the date in list 2, well, it's the same date. So it appears to be changed as well. But if you remove something from one of the lists, it does not remove the corresponding element from the other list. Right? The lists are independent. The stuff inside the list are not. Right? Lists and sets, they both have constructors that will take in a collection of any type. It will take in any list or set and copy that list or set. Whoa, sorry. Okay, so if we change our copy constructor so that we now own the internal list, right? So now I make a new array list, and I pass in the list that I want to copy from the other model. Right? So what's happening here? Now we've got a shallow copy of the other lists. Of the other object's list of triangles. Right? So a new list, no new triangles. Right? So what does the picture change to? Well, the picture changes to the following. Right? So P1 is that model there. Right? It has a list of triangles, which is up here. Right? Inside that list of triangles, you see there's a reference to that triangle there, and there's a reference to the triangle there. Right? Now, P2, right, is a copy of this object here. So there's a new object here. Right? Inside the copy constructor, we made a new list. Right? So that that reference refers to a different object than that reference. Right? In other words, there's a new list somewhere. Right? And so there's the new list over here. Right? So now you've got 2 polygonal model objects and 2 lists. Right? Each model has its own list. But the stuff inside the list is identical to the stuff that's inside the other list. Right? If you modify this list, then this list changes, but the second list does not change. Right? If I change the element at address 1000, right, in other words, if I change that triangle somehow, then both lists, right, have a reference to that triangle. So both lists see the modified triangle. Okay, so P1 has 100 triangles in it. I'm going to make a copy of it. Right? I'm going to clear model P2. Right? This time using our newly modified copy constructor. Right? So when you clear P2, what's its size? Well, it's 0. Right? But does it also clear P1 in this case? The answer is no. Right? So when I clear P2, all the stuff inside P2 goes away. Right? But P1 doesn't change. Right? So P1 stays at size 100. So in this case, the answer is B. Right? Your lists are independent. Right? Your polygonal model objects are independent. The lists are independent inside of them. All right, what about this one? So P1 again has 100 triangles. Okay, so I've got P2 is a copy of P1. Right? I'm going to get triangle 1. I'm going to get the first triangle from the list for P1. And I'm going to get the first triangle from the list for P2. Right? Are they the same object? The answer is yes, they're the same object. Right? You just go look at the picture. Right? Is that number there the same as that number there? The answer is yes. Right? They both refer to the same triangle. Right? So in other words, T1 and T2, they're actually the same triangle object. Okay. Now, what happens if you decide that a polygonal model is a composition of triangles? Right? So in other words, a polygonal model owns its own triangles. Right? So what does that mean? You have to own your own list as well. Because if you don't own your own list, you don't own your own triangles. Right? Someone else can take the list and modify the triangles in it. Right? So you also have to own your list now. So now I have to own the collection, and I have to own all of the individual triangles. Right? So what does that mean? That means you need a deep copy of the list. Right? So a deep copy of a collection means you make a new collection object, and you make a new copy of every object that's inside the collection. Right? So in this case, I have to make a new list and have to make a new copy of every triangle that's in the list. Right? So now the picture changes, right? So now a polygonal model really is a composition of 0 or more triangles. Right? How do I perform a deep copy? So in a deep copy, now you have to use a loop. If you can actually copy the elements in the list, then you have to use a loop. Right? So to make a deep copy of an existing list called dates, I make a new list. Right? This time it's an empty list. Right? I loop over the list that I want to copy. Right? For each element in the list that I'm copying, I make a new object and add that to the copied list, to the new copy of the list. Right? So it's dcopy.add new date. Right? So I'm making copies of new date objects, adding references to those date objects into the new list. Right? And there is no way to get around this. You have to write the loop yourself. Okay, so in the copy constructor for polygonal model, if I decide to change to composition, right, what do? So I make a new list for my list of triangles, for this object's list of triangles. Right? I loop over the other lists of the other model's triangles. Right? So for each triangle T in other get triangles, right, I'm going to add a new copy of a triangle to the newly created list. Right. So now what does the picture look like? So if I use the new copy constructor, right, there's P1, there's P2, right? They both have their own lists, right? So P1, its list has the triangles at address 1000 and 1100. Right. P2, right? Notice that what's inside that list? Right? Now the triangle objects are different. Right? So now there's a triangle object at address 2000 and a second triangle object at address 2100. Right? So now I've got 4 triangles. Right? 2 polygonal models, 2 lists, 4 triangles. Right? Independent copies of everything now. So on the next slide, you'll see the other 2 triangle objects. Right? So the object at address 2000 is a copy of the address of the object at address 1000. Right? The object at address 1100 is a copy of the object at address 2100. Right? But they're independent objects. So now, if I change that triangle, right, the corresponding triangle in the other object does not change because it's a separate object. Right? So now your 2 polygonal models, they really are completely independent. Right? Changing a triangle in one of the models does not change a triangle in the other model. Okay, so if I make a new polygonal model, P2, and I clear P2, what's the size of P2 and P1? Well, P2 is 0. P1 doesn't change, right? Because the lists are separate now. Right? So that's B. This is the same. Oh, this is a similar example as before. So P2 is a copy of P1. Right? I'm going to get the first triangle from P1, and I'm going to get the first triangle from P2. Right? T1 equals T2. So are the 2 triangles the same object? The answer is no. Right? The first triangle from P1 is there. The first triangle from the second object is from the second model is there. Right? That's 1000. That's 2000. So they're different objects. Right? So that one's false. Are the 2 triangles equal? The answer is yes, they are equal, right? Because they're copies of one another, right? So the triangle object here is equal to the triangle object that's here, right? So they have the same state. In other words, they have the same points, but they're different triangles. They're different triangle objects, right? Okay, so that's what happens when you have a composition of a collection of some kind. Now, this keeps on going, right? So you have a collection of collections. So I have a list of lists, right? You now have to decide, right? Do I own the original? Do I own the outer list? Do I own the inner lists? And inside all of those inner lists, do I own the elements in those lists? right? And so it keeps on going and going and going and going. Implementing a composition is not always as straightforward as it seems, right? Sometimes copying objects becomes difficult to do, right? In particular, when you have collections of collections of collections, right? But fortunately, those situations are somewhat rare. And you won't actually see a collection of a collection in this course, right? But you might run across one should you end up programming professionally. Okay, any questions? All right, it's 20 after the hour, so I'll end the lecture there and see you 2 days from now.